So my name is Brian Hyder, and I am the co-founder and CTO of PencilBlue. We're a startup right here in the Triangle, and we're a Node.js CMS built for the cloud and the way we use the web technologies today. And we've built our entire platform on the mean stack. And what this means is that we ran into some interesting challenges along the way. And as a startup, your resources are really limited, and you want to use them in the most efficient way possible. And so we're here today to share with you our experiences with the mean stack, because choosing the right technologies for your project can give you a significant competitive advantage. So we want to be able to empower you and your teams to make the right decisions when it comes to the right technologies for your project. So we're going to cover each component of the mean stack. And along with each component, we're going to break it down into three critical areas: planning, development, and deployment. You can also follow along on the presentation at pencilblue.org/presentation. And just a quick heads up, there are a few extra slides in there because we had to cut it down for time. So you get the director's cut. So the first component that we'll talk about is MongoDB. It was originally created back in 2009 by 10gen. And as you've noticed, 10gen is no longer, right? They changed their name to MongoDB Incorporated to align with their flagship product. It's document storage and stores everything in BSON, which is binary JSON. So the database is the foundation of every project that you build. And so you want to make sure that the strengths of your database align with your most complex problems. So when we started building PencilBlue, we really didn't take the time to do the research to figure out which databases would really align well with the complex problems that we knew we needed to solve. We knew that we needed something that was easy to install, something that gave us the flexibility that we would need in the early prototyping phases, and we knew we would need something that would help us get up and running as fast as possible. It wasn't really until we dove in to the complexities of the objects that we had in our system and started to address the scale with those objects that we realized that Mongo may not have been the right choice. I'm not saying that it isn't, but I'm saying that we didn't take the time to really dive in and POC with a couple of different databases to figure out if it aligned properly with our project. Because what we found is that the complexities of the inter-object relationships really wasn't something that NoSQL was really able to handle well. So this brings me to the point of prototyping versus production. So our experience has showed that Mongo has gotten us up and running and building prototypes faster than any other database we've worked with. However, once we got to that production phase and our schemas stopped changing as rapidly, we realized that a relational database may have been the better choice. So once again, the point is always take the time to build out the POCs, build in the time to take a look at other databases and other options to figure out what aligns with your particular project. One of the things that we really loved about Mongo was the fact that it gave us a great deal of flexibility. And one way we leveraged that flexibility was building out the object services. CRUD operations we found were about 90% the same. So when we started building PencilBlue, we built out a specific service for every system object. But as I just mentioned, we kept running into problems where it was duplicate code. And that is a pet peeve of mine. And so we started to do this abstraction. So because of the flexibility of the JSON and the document storage model, this abstraction becomes very easy. And you can do 90% of the same stuff within a base service and only have to really worry about data formatting and validation routines for the specific objects that you're building for your system. But in terms of flexibility, there was one piece that we overlooked. In one particular case, we were tracking events. We had a mobile SDK that was running on an iOS and an Android device. And we had a bit of confusion. We had one device that was sending latitude and longitude coordinates back as strings. And we had the other platform sending it back as floats. Well, Mongo doesn't care what format you put that data in because there's no schema to enforce. So what happened was over time we started collecting this data. And then we went to put a geospatial index on it, and the index fails. Well, this isn't the fault of Mongo. This is really the fault of the developers because we weren't consistent and we didn't enforce the schema that we expected. So how did we resolve this? Well, most people would say, well, your validation should have caught this. However, the mean stack forces you into a bit of a predicament because the way our validation routine worked is we were checking for is not a number, right, as you would normally do. But with JavaScript, we weren't doing strict type checking, so it slipped through the cracks. So the flip side of that would have been, well, what if we had used a relational database? If we had, then we would have had that second layer of validation because that strict typing would have already been there. So it's very important to take a look and understand what data that you really want to put into the system and make sure that your team adheres to the standards that you have. So that flexibility in Mongo led us to an interesting discovery that if we started building in the time and the sizings for our user stories to start documenting all of the objects, all of the indexes, that it really increased the overall time for everything. It came with a few advantages. So now we could go back and very easily look at the standard we had set forth for each of our projects, as well as it helped with the quality assurance side of things because the QA people could go back and take a look and see exactly what they needed to test for because they had that documentation in front of them. And conflicts between the two could be resolved very easily. So once we started building out this documentation, we noticed that we needed an auditing feature. And we also noticed that in the early days, our schemas were changing very quickly. So we came up with a set of common fields that we added to every object type that we put into Mongo. And so you always have your created and your last modifieds, and those are easy, and it's something that you can always index on. However, the one that's not always so recognizable is the doc version. And the reason this becomes very important is because when your schema changes and you need to upgrade specific objects within your collection, you can save yourself a lot of time by just querying for that particular object version and know that it's going to be a particular format that you can upgrade and move on. And this lessens the impact to any production system that you already have out there with versions of different objects. So what is the one thing you should never do when you're trying something new? And the answer is never run an untested query against production. And this is the lesson that we learned one afternoon. We were collecting these events, and we wanted to be able to put all of this geospatial data on a map, right? Nice Google Map UI, and plot it all out. So we spent a few minutes, and I underscore a few minutes, looking at the documentation and trying to figure out how to build this geolocation query. As a startup, we were a bit cash-strapped, and so building out this test environment really wasn't an option for us. And at this point, the data was so large that dumping it and moving it into a local system was a bit more painful than we really wanted to go through. I really wish I had just done the dump, because what happens is we fired off the query on the left, and what happened? Well, it used up every ounce of memory in the system. And the only way that we could get queries to start coming back again was to shut that process down and restart it. So even though we had the geospatial index out there, the intensity of using the near operator was really more than the medium-sized instance could really handle. So it got to the point where we did this a couple of times. Yes, we did it more than once. And we were ready to scrap the whole thing and move to Postgres and use its geospatial capabilities. But we took one last look at the documentation for Mongo. And what we realized was that there was more than one geospatial operator. And so we came across GeoWithin, and this one little nugget of information that was on the GeoWithin operator's documentation and not the near operator's documentation. So the point becomes, yes, the documentation is out there, and it is very good when it comes to Mongo, but these little nuggets are hidden all across the site. And so anytime you see one of those links into a subsection, go ahead and read that one too, because chances are you're going to be able to save yourself a little time. So once we've got this UI and we've got all of these events coming in, we needed to address scale. And so we started looking at the different ways that we could host Mongo. And the reason we needed to scale so quickly is because we started expanding to other apps. And so the events kept coming in faster and faster and faster, almost at an exponential rate in the beginning. And so we needed to go from our 2-node cluster to a full-blown cluster, right? And so Mongo forces you to make your cluster at least 3 nodes, right? Because you need a master, or a primary, a secondary, and then at least that arbiter to break the tie between the two. So we looked at AWS, and we looked at the recommendations that they had. And they recommended at least an M1 large with at least 1,000 provisioned IOPS. Well, what this really translates to is about $144 a month per server. So we learned very quickly that this probably wasn't the right option for us being a startup. So we started looking at other options, mostly the managed options such as Mongo Lab and Mongo HQ. And while they are predominantly cheaper by the gigabyte, they come with some drawbacks, predominantly 2 drawbacks. The first one being you have to share your resources on a particular server with other companies because they're all multi-tenant. And if you have sensitive data, your clients may not appreciate that too much. The other drawback is that, totally lost my train of thought. All right, so we're going to skip that one. And so then you get down to Linode. And if you don't have exponentially growing data, then what you can do is go with something simple like Linode, get a medium-sized instance for $20 a month, put backups on it, and that will get you moving in the early days until you can figure out what's really good for you and your project. So as a developer, one of the things I am not good at is DevOps and being able to manage the infrastructure that I need to be in place to be successful. And so one of the things that Mongo has done that they've done a great job at is putting in place the Mongo monitoring service. And this is a free service that they've put out there. So all you have to do is deploy one small process, and it will pump all of this data about your entire cluster back to this one management console. So the advantage of this is that now Mongo really knows about problems on your cluster before you do. And we've seen instances where they have contacted us about problems that we didn't know we had. So now that we've got our foundation in place, we'll talk a little bit about Express and the other frameworks that are out there. And for those that are unfamiliar with Express, it's a routing framework that was originally built by one guy and then picked up by StrongLoop recently. And when it comes to frameworks, you need to make the decision of whether or not you really need it. Some projects it's right for, others it's not. So we compiled this list of questions that you and your team can ask yourself to help you decide whether or not you really need that framework. Because it sits at the bottom of your application stack, you really need to be careful when making that decision. So one example of a project that I've worked with that needed this kind of framework was one that was very API driven. We wanted our developers to focus solely on what was important, which was building out the APIs. We realized that using Express was a good enough, fast enough framework to get us up and moving and concentrating on the things that really mattered. An example of a project that we didn't use a framework for would be PencilBlue. Because it's a CMS and we support multiple themes and prioritized routes, that complexity was a bit more than Express 3 could handle at the time, and so we chose to do it custom. Although I will say that a lot of the things that Express does makes it very easy to build out the customized routes that you need. So that's something else to take into consideration. The other thing to keep into consideration is that you want to make sure that your project aligns with all of the vendors that you choose. So another reason for us not using a framework with PencilBlue was because we wanted to make sure that Express was going to continue along the same path that we needed. We knew that if your particular vendor gets picked up by a larger company, they may change their direction. They may change their vision of where they want to go. So we made the decision to go custom. And when using Express, you have all of these different middleware pieces. You have all of these plugins. And you have to be very careful that you don't get bogged down in trying to figure out how to piece it all together. Otherwise, you really do end up with the Rube Goldberg machine of software. In the end, it works, but you probably went into a roundabout way of doing it. And at the end of the day, no matter how much searching you do, sometimes Stack Overflow is just not going to help. Which brings us to the forum conundrum. How many people here have been searching for the right answer and seen that green check mark of hope, right? We've all done it. We've all done it. And then when you read the answer, and it has absolutely nothing to do with what you're looking for, because you look at the date and you see that it's almost 3 years old. And we all know that within that 3-year period, technology has changed so rapidly that it has absolutely nothing to do with what you're trying to accomplish today. And then beyond that, it gets worse, because you read comments at the bottom that say, oh yeah, here's an example, but by the way, they've changed their API, so you should probably go look at them. So you're stuck once again. So the lesson we learned from that was it's okay to use this middleware, it's okay to use these frameworks, but choose the frameworks based on their documentation, right? Not the documentation that you have to go and Google for. Because at the end of the day, the one thing that is always missing from these forum posts is the version of the frameworks that you're actually trying to figure out how to use. So I wanted to show a simple example of Express and how easy they've made it to get it up and running. And it really does 3 simple things. It initializes itself, it configures itself, and it starts listening for incoming connections. And Express has been very good about keeping this basic format throughout the major versions that it's had. And I believe they're up to version 4 now. But just because Express does it doesn't mean that the other frameworks that you'll encounter will do the same thing. We've seen multiple times where everything works beautifully with your framework. But you also see this one bug that comes up, and it fits the one use case that you need to try and solve. And at that point, you only have a few options. You either A, have to wait for somebody else to find it and fix it. You have to fork it and fix it yourself, but then you're stuck maintaining it. Or you submit that pull request and pray that they pull it in for you. Either way, this really halts development for the rest of the team, at least for some amount of time. And then, even if you can get the rest of the team moving around this particular problem, you're now building on top of that problem and may have to go back and address different things once the fix is in place. So you just want to be mindful that whenever you choose a framework, understand that you may have to upgrade in the future. And the longer you have to wait to do that upgrade, the greater the chance it's going to affect and have that ripple effect all the way up through every layer of your code. So now we've got the foundation in place. So now we can talk about the client side. And Angular is an MVC framework that was originally created as proprietary software in 2009 and then originally released open source in 2010. So when we were looking at front-end frameworks for PencilBlue, we knew we had a few options. We could just do jQuery, we could look at React, we could look at Backbone, we could look at Ember, and there were 1,000 other frameworks out there. But what was really key to us was that we needed a lot of flexibility. And so we came across Angular and we saw, hey, Google did it. Well, not really. In fact, it was really started by Misko Hevery, known on Twitter as the father of Angular. That's how he coined himself. Not judging one way or the other. But the fact that Google did eventually pick it up and back it and is now being the maintainer of that means that it's going to have a long shelf life. And it means that it's going to have large community support and the resources to build the documentation around it. So we knew that Angular would be a good choice for PencilBlue because it would be able to be bent to the will of the developers that were going to be developing with it. And the best analogy that I've come across for Angular is that Angular is a tank. You can take it anywhere, you can do anything. But at the end of the day, you don't always have to blow shit up. Sometimes you just need a small sedan to get where you're going. And what I mean by that is that for small projects, the time to set up an entire Angular application may not be what you need. If you're just simply doing a quick prototype, a 3-page website, why not just take a small framework and move ahead as quickly as possible? Because Angular is a new technology, whereas some of the others have been out there for a while. So you and your team have to decide what you're comfortable with and if you're ready to get up and over that learning curve. So Angular promotes this single-page application design. And one of the things that you really have to take a look at is whether or not you need your site to be crawled. The single-page applications, because they depend so much on JavaScript, aren't rendered once they're served up the way the human eye sees them. But this is starting to get a little easier. Back in May 23rd of this year, Google announced that their crawlers were going to start executing client-side JavaScript to get closer to the way the human eye visualizes a web page. So what this means for us as developers is that when you build out these single-page applications, you have a couple of decisions to make. You either A, go with a server-side rendered page completely, the basic traditional model that we've known for years. You go solely with single-page application and risk not being crawled by some of the other crawlers. Or B, a hybrid model, which makes things a little more complex, but then gives you the flexibility. And this is exactly what we did for PencilBlue, was we took the time to build in this flexibility so that things like our landing pages and our publicly available pages, those without authentication needs, to be easily crawled by all of the crawlers out there. So here's a simple example of what Angular will do. You just need one small snippet of HTML and a directive like ng-repeat. My personal favorite because it keeps me from having to do table row, table row, table row, div, div, div. And then you have simple JavaScript on the right that does all of the heavy lifting for you. And all you're really doing is creating a module and a service and a set of data functions that return all of this data or do all of this heavy lifting for you. And then in the controller setup, all it's doing is doing the binding for you so that all of those list items are doing nothing but watching for that data when it comes through. So Angular promotes this sense of separation of concern, right? They promote keeping your UI completely separate from your API. And with this comes a small bit of overhead because you've separated out those layers. It means more files to maintain, and it means potentially a little more code. However, the upside to that is Angular is encouraging this design, and it's finally bringing order to the chaotic world of client-side JavaScript. So in terms of smaller projects, Angular might be a little bit of overhead, but for larger projects, you're going to benefit from the separation of concern and the extra set of layers. The other major benefit to this is the fact that finally your client-side JavaScript is completely testable. And now that you've separated your UI from your API, you should test both independently as well as together. Frameworks like Jasmine have made this very easy because they take a very semantic approach to testing. You literally just describe it, and then it takes care of everything for you. So in this particular example, all it's doing is setting up 2 quick tests that make sure that your login controller is there and defined, and making sure that your service is there and defined. So now we have this single-page app, and it's supposed to be separate from our API. So we have to ask ourselves, OK, now that I have 2 separate components, how the hell do I deploy this thing? Well, there are really 2 considerations to make. The first one is, how much data do I need to persist on the back end? Is there anything that I need to bootstrap when I serve up that initial single-page application? And if the answer is yes, I need security tokens, I need X, I need Y, then maybe it's wise to deploy it on the same type of infrastructure that your API is built. And the reason for this is because you're probably going to use a lot of that same code that you've written for your API to bootstrap your single-page application. And so you don't have to maintain all of that duplicate code. If all you need is just to quickly serve up your single page application and it's all static content and reaching out to other services, use something like Apache, something that's very fast and efficient at serving static files. So now we really get to the core of it, Node.js, server-side JavaScript that runs on top of Google's V8 engine. So now that we're running JavaScript on the front end as well as the back end, everybody says it's JavaScript from one end to the other, it's green pastures. Now your front end devs know exactly what your back end devs are doing, and this makes the candidate pool huge, and hiring should be a breeze. False. So a perfect example of this is we were looking for a full stack developer, and we wanted somebody that knew Node and knew Mongo and knew Angular, and it's really hard to find those people, right, because the technologies are so new. So we thought, well, because there are a lot of JavaScript developers out there, the candidate pool should be pretty large. We found that to be completely false. What we found was that the developers' knowledge of the language was never a problem. It was the mindset that they had. We found that front-end developers had a great eye for aesthetics and were very user experience friendly. When we started looking at the back-end devs like me, for example, we can't draw stick figures, but we know how to scale. So it was a really difference in a mindset that we had to take a look at and figure out where we were willing to compromise. The other interesting thing that we began to see on resumes was multiple years of Node.js experience. And while that is possible, it's not exactly plausible. And so when you're looking at these resumes, make sure that somebody's not blurring the lines between JavaScript and Node.js. Because at the end of the day, there is a difference. And typically, people are more front-end or more back-end. So if you can't find the right candidate, what's the point in using Node? Well, one of the reasons is that there are some major players out there that are using Node.js. Walmart Labs is a heavy contributor to the core. LinkedIn runs their entire mobile API on Node.js. You have other startups that are flocking to it as well, such as Uber, if anybody cabbed it here today, right? And if you look at the stats on GitHub, the majority of the new repositories coming up, the higher percentage of them are JavaScript repositories. So the big pain in Node.js is debugging, right? It's a complete mind switch from the traditional linear programming model. Everything is asynchronous. And so to try and figure this problem out, a couple of guys got together and they started this open source project called Node Inspector. And they created a visual debugger for Node.js. And for simple applications, this works absolutely wonderfully. But as soon as you start to cluster out your application, there's a bug for earlier versions, 10 and under, that hasn't been addressed yet. And it ends up killing the connection to the visual debugger as child processes come on. So in terms of clustering, what does that really mean? So with a traditional server like Apache, you have the ability to spread out across all of the cores automatically. With Node, you kind of have to manage some of that yourself. Well, the advantage to that is that it encourages you to go ahead and build that stateless app and control all of this yourself and be efficient at it. So what I've done is I've put together a small example. And what happens is the initial process for your application starts up. And it says, hey, am I the master process? If yes, then my sole job in life is to be the nanny, is to spawn all of these children off and make sure that they're playing nice. And if one dies, quickly replace it so that the parents don't notice. So when you're a child, you spin up and you recognize that you're a child, and you start doing all of the heavy lifting and handling all of those incoming requests. And the one handy thing that the cluster module does for you is it allows each of those child processes to listen on the same port. So you don't have to do any crazy port management on the back end. So once you've scaled out, you have a lot of different options because everybody wants to go to the cloud and scale up and scale down because it saves you money to be in these elastic environments. So you have all of these different providers, right? And they all specialize in a bunch of different areas. When you're dealing with Node.js, you can go to a specific provider like Nodejitsu, who specializes in these Node.js deployments, or you can go with any of the other cloud providers. Because at the end of the day, Node.js promotes stateless applications. And so you really have to think about scale from the get-go. And if you do this, you will thank yourself later because you will be saving yourself time and money if you go ahead and take care of that in the long run. However, if you do want just a small managed instance, check out Linode. And the reason is because you can do things very cheaply there if you're willing to do a little bit of management yourself. So at the end of June, PencilBlue was looking to do its first launch. And we knew that we didn't want to break the bank, but we also knew that with the marketing and the promotions that we had been doing, we knew to expect some traffic. We really didn't know how much, but we were confident that 2 VMs would handle that traffic for us. And so we chose Linode, and we set up 1 load balancer, 2 VMs with 2 cores, and 1 medium-sized instance that had a lot of memory. And while this does have a single point of failure, we added backups. So we felt confident that we could get through launch with this configuration. And at the end of the day, this was only costing us $70 a month, which is nothing compared to what you would spend in an AWS environment in comparison. So to recap things, Mongo, it's flexible, it's easy to install, and it's quick to get developing on, but you're going to run into problems at scale, especially around cost. When it comes to Express, it's good enough. It's fast and it's efficient, especially if you only have simple authentication models and things along that lines. But keep in mind that when you go to upgrade these frameworks, you could be looking at potential downtime in terms of the technical debt that you've accrued. When you look at Angular, it's a battle tank. It will do absolutely anything that you want it to. But at the end of the day, it might be a bit of an overhead for small projects. And when you look at Node.js, it's fast and it's efficient, but it is absolutely horrendous when it comes to having to debug that one problem that you just can't figure out. So the entire point of all of this is you can use mean, and I strongly encourage everybody to try it. But at the end of the day, the choice of technology is really up to you. There's nothing wrong with the LAMP stack. It's been around for years. There's nothing wrong with the mean stack. People are being very successful with it. But you really have to understand the technologies that you were using and figure out how they apply to your particular project. Thank you, everyone. I appreciate it. So any questions? Yes, sir.
Going over a lot about the particulars and pros and cons of each one. As far as how about the integration? Can these be switched down and say, oh, well, I'm going to use this other one instead of, I think you had Redis or something like that instead of Mongo or something like that. Do these fit together, despite their cons, these fit together well?
They do fit together well. Think of the mean stack as really a set of guidelines around technologies, right? In my mind, when I think of mean, I think of more of the movement to go to the cloud and to take the new technologies and being more flexible than the traditional LAMP stack has been in the past, right? It's really more of a revolution around the new sets of technologies and getting people out of that mindset and that comfort zone of the old way of doing things and a shift towards looking outside the box and trying something new. So each of the components are really decoupled, except for Node.js and Express, right, obviously. But beyond that, the big advantage is that 3 out of the 4 components are JavaScript. And then when you look at Mongo, it's already in JSON format, right? So that's the reason that they fit well together, but they're no means tightly coupled. Any other questions? Excellent. Well, thank you, guys. I appreciate your time this afternoon.